forum for augmented reality here at Mobile World Congress. The Khronos group is proud to present augmented reality, give you an overview, and show you what's happening in the market today. My name is Eric Narecki. I'm one of the work group chairs in the Khronos group, helping to develop the standards that will drive the market for tomorrow with multimedia and augmented reality. So on the agenda for today, we're going to start off with an overview of augmented reality by Neil Trevitt from NVIDIA. He's going to show us how open standards and Khronos can contribute to driving the market forwards and enabling a market position for augmented reality in devices. Following the overview, we're going to hear from 4 different silicone vendors about how their silicone and systems on chip can contribute to enabling the market for augmented reality in today's devices. And finally, we're going to have a panel discussion. So get your questions ready. We're going to have the panel is going to be led by Christine Perry. And so you'll be able to ask questions to the panel about what augmented reality is and how it applies to the market for today. Okay. Neil?
Thank you, Eric. It's great to see such a great audience here. Welcome to the MWC Moonbase. And we're going to be talking about augmented reality all this morning. And we're going to start out by trying to answer 3 questions. What is augmented reality? When is it going to happen? And why should your company care? And what is going to be the commercial opportunity that it represents? A lot of people have, I think, different ideas about augmented reality and what it actually means. And if you look at some of the industry analysis, things don't look too good because this is the well-known Gartner hype cycle, which is the way that almost all new technologies that are breaking new ground reach the market. They go through a hype cycle, then reality sets in, but eventually the technology settles out and you get real product shipping in real markets and people make real money. According to Gartner, we're just about to dip into the roller coaster ride, but I don't think that we have to agree or necessarily accept that analysis. And one of my favorite quotes is from Alan Kay at Park some years ago that said the best way to predict the future is to invent it. And I think that's why we're seeing such a turnout here this morning. A lot of people recognize the opportunity, and I think the industry is beginning to come together to invent the technology pieces and the ecosystem that we need to make augmented reality a real market presence. And this forum is going to focus on the contribution from the hardware vendors, the silicon vendors, which is really, I guess, the first step in a chain of events that we're going to need to make augmented reality affordable and accessible to real consumers in everyday applications on everyday devices. So what is augmented reality, and why do a lot of the analyst community think that it's 10 years away? Well, it is a challenging application. Unlike most other mobile applications, you need all parts of the mobile system to work together in pretty seamless harmony. Now, games on the whole are really just a 3D output kind of thing. Photography and video capture on the whole is pretty much an input kind of thing. But augmented reality is gathering input from multiple sensors that need to be synchronized, that need to be handled in very sophisticated ways to sense what the user is doing, to sense what's out there in the scene and the environment, to track and locate key objects and actions in the environment, create sophisticated data and augmentations that provide useful information to the user, and then combine it and composite it all together, all in real time, all with low power. It's actually a pretty difficult and challenging thing, but we are getting close, I think, and you'll see some of the presentations from the silicon vendors today, where at the silicon level, we're beginning to get the capability where this is really becoming to be a type of application that is in reach and can start shipping in the market very soon now. Now, this picture is kind of the sci-fi where we would all love to be, with sort of non-existent virtual displays and people just poking and touching them. That's kind of where we want to head. But of course, we have to go through a lot of much more down-to-earth steps before we reach that future. And a brief history of augmented reality on mobile so far, I think you can largely split it up into a number of recognizable advances and steps. A lot of the people here that might have first come across mobile augmented reality probably used applications like Layar or Wikitude, which in their first incarnation at least were based not on processing the camera input, but were based on taking the sensors, the GPS and compass sensors, and then augmenting information about the general locality around the user on a geographic basis. A lot of people beginning to hold their phones up like this, but you weren't locking the augmentations to the pixel level. The next big step was to begin to process the camera input, and the first step along this path of doing camera processing was to be able to recognize and track planar objects, flat objects, and then begin to synchronize augmentations to the pixel level over those planar objects. And you have some marketing applications. You can have posters and packages that come to life with augmentations, for example, when you point your mobile device at them. And there are many applications now shipping in the market that do precisely that. I think the next stage that we're looking at now is where the tracking becomes much more sophisticated, and we can track much more than a planar flat surface. We can begin to track real depth in a scene, because of course any environment that we find ourselves in has multiple objects with depth. Things are spaced out around us, and we're beginning to find trackers that recognize that and are able to cope with that extra dimension of complexity. And this is going to be, an important step forward, and really we need this to continue to advance to enable these mobile devices to track more and more complex environments going forward. So these visual-based pipelines, what are the key steps? And I recognize many faces here, so I'm a little scared because many people in the audience know more about this than me. But for those of you that are new to augmented reality, the basic step is the camera input is used, and it's used in two ways. The first way is the camera input is sent off to the tracking subsystem. Very often the tracking subsystem today is run on the CPU. It's quite sophisticated software, so it needs to run on the CPU traditionally. And you're locating and tracking objects. And you're also taking in the sensors, the motion sensors, the gyro and inertial sensors, and you're generating a camera to scene transform. So you're locking and knowing where the camera is in relation to the outside scene. That lets you generate 3D objects and information that can be locked precisely to the scene as it comes in through the camera. The other use of the video stream is you send it to the output screen, and then the augmentations and the video get composited together to create the augmented scene for the user. To make all that happen in real time at low power, going forward is going to need a lot of hardware acceleration. If we do all of this on the CPU, it's going to take too much power, it's going to be too slow. So we need APIs to let the software development community who are building these augmented reality applications to tap into the power of new generation silicon and accelerate, ideally, everything that you see here on this flow diagram offloaded to fast, specialized, power-efficient hardware. And that's the role that the Khronos group plays. For those of you who haven't come across Khronos before, we are an open standards organization. We're open in two ways. We're open to any company who wishes to join. And secondly, our standards are open too. They're available to anyone who wants to use them, and they're available royalty-free to the industry. We focus on APIs that connect the developer community to the silicon. So the silicon guys, we recognize we can build the best chips in the world, but if we don't really think about how to make that power accessible to software developers, it's no good to anybody. So we focus on low-level APIs very close to the hardware for graphics, for parallel compute, and now increasingly for sensor processing, vision processing, and video and audio processing. We have a good IP framework, so the standards that we create are protected in the industry. And we're very motivated because the right APIs at the right time can really enable the development community, and the right silicon at the right time with the right acceleration can give you easily a 10 times improvement in either power or performance, and sometimes both. We have about 115 members. We have pretty well everyone in the silicon community. We have key platform vendors like Samsung, Google, Apple, and others. But we have a lot of software people too, tools vendors, application vendors, compiler vendors, framework vendors. So we have a good representation from the industry, which is important because Khronos has been driven by its members. We want to be creating the APIs that's solving real problems for real companies making real money in the market. So over the years, it's been interesting to see how the APIs that Khronos creates have been changing in character to meet the evolving needs of the industry. When we first started out about 12 years ago, we were primarily focused on APIs for the high-end desktop. Opengl, many of you might be familiar with the cross-platform 3D graphics standard. Opencl for parallel computation. Over the last few years, though, of course, mobile has become the platform where lots of innovation is happening in the industry. So now we need mobile APIs that provide almost the same level of sophistication as you can get on the desktop, but do it at much lower power levels and much lower footprint for cost-effective deployment in the mobile space. Where we are right now, and augmented reality is really the key driver in this. Yesterday, the APIs that we created could exist independently of each other. We could have a graphics API, we could have a video API, and they didn't really need to talk to each other that much. It didn't really matter. Now we're trying to enable applications like augmented reality, the graphics and the video, and all the other subsystems, the sensor fusion has to be seamless. And these APIs, they have to work together. And I'll try and show you in the next few minutes how we're working to make the Khronos APIs into a coherent API ecosystem. Then last but not least, HTML5. The web, and particularly with HTML5, is becoming the promise of a cross-OS, cross-platform development environment. So we don't just need native APIs anymore. We need to start enabling web developers to have access to the same level of sophisticated acceleration as native application developers. We're not quite there yet, but we are making the first steps, and I will show you how that's working out at the end of this presentation. So that's a quick snapshot of some of these APIs that you're going to hear the silicon vendors talk about in more detail. Opengl Es, probably many of you are familiar. It's probably the most widely deployed Khronos API for 3D graphics. ES stands for embedded systems. So it's the Opengl that's now close to 20 years old and has all of the latest 3D functionality streamlined down for deployment in mobile and embedded devices. It's now shipping in hundreds of millions of devices. Pretty well any 3D capable device is running or capable of running Opengl Es. Opengl Es 2 is the latest version. It's fully programmable, and it's capable of supporting some of the highest-end gaming engines, like Unreal Engine 3 from Epic. You're beginning to find console-class games and content beginning to ship on these mobile devices. It's getting pretty hard to tell the difference between a current generation console and the latest generation mobile devices. We have Opencl, so G for graphics, C for compute. Opencl is a framework for heterogeneous parallel programming. It means, what does that mean? That means that you can write software that will run across any of your processing elements you have in the system. It might be multi-core CPUs. It might be a programmable, highly parallel GPU. You might have DSP chips in there. Opencl provides you a framework where you can write your software once and then run it in parallel across any of the compute resources that you find in your system. So there's a couple of APIs to find out what's in your system. You have a parallel programming language, which is very close to ISO C99, where you write kernels for your computation. And then you have a runtime API that lets you compile and distribute your kernels across your parallel resources and bring back the results. We're never going to need an Opencl ES because we learned our lesson from Opengl, and the core Opencl specification already has an embedded profile built in to Opencl, the main specification. So we're already beginning to see Opencl beginning to ship on mobile devices, primarily first with the embedded profile on mobile. Opemax AL is a API that provides a lot of functionality around the camera, low-level image processing, pipeline imaging close to the sensor, and video processing with AV sync, audio sync. It's an object-oriented API. It's easy to use. Some of you might have come across Opemax IL, which is intended for multimedia framework integration. That was never really intended for portable applications. Opemax AL is the application layer of the Opemax family. And so if you're using developing applications that uses camera, imaging, and video processing, I strongly recommend you check out Opemax AL. It's going to be easier and more portable. And I think Opemax AL is going to be key in enabling some key use cases like advanced imaging, like computational photography, HD video teleconferencing with full hardware acceleration, and of course, augmented reality. We have Opengl Es, S for sound or audio. So what Opengl Es does for graphics, Opengl Es does for audio. It's object-oriented, just like Opemax AL. It gives you advanced audio, including full 3D positional audio, which can be key for many augmented reality applications. One of the key problems I mentioned earlier was getting the video and the graphics subsystems to work together. It's surprisingly hard to get the graphics and the video communities to cooperate together. It's been an outstanding problem for many years, but now we actually have a solution in place. We can have, for example, the video subsystem using Opemax AL, the 3D GPU using Opengl Es, and now we have a new extension to the EGL API, which isn't as well known as Opengl Es. It's often the forgotten API, but it's becoming increasingly important because it's the API that acts as the hub that lets the other APIs communicate together. And EGL Stream is the latest generation of the EGL functionality, so we can have a stream of video frames passing from the video subsystem into the graphics subsystem through a high-level, easily understood API that lets the application developer control that stream, but not get too bogged down into the details. And it gives us a level of abstraction so the hardware vendors can optimize that transfer from video to graphics with no copies for their particular architecture. Some of the newest APIs that we have are expanding the reach of the types of hardware that the Khronos APIs are handling. Stream Input is our second newest API now, and it's trying to address the issue that mobile devices are getting richer and richer sensor networks built into the device itself. We need the application developer community to be able to tap into the power of the sensor network, but to do it in a portable way, so you don't have to rewrite your application for every different type of sensor you find on different types of platforms. The way that Stream Input is attempting to do that is to define semantic level information. So an application can request from the system, can you tell me about skeleton tracking information if you're doing a Connect type game, or can you give me gesture information if you're wanting to do a gesture UI, or define virtual sensors, such as tell me if I'm in an elevator, or tell me if I'm being driven in a car, give me a callback, or if I'm being carried in a hip pocket, or I'm being carried in a backpack. The sensor guys know how to use the sensors on a device to give that kind of magic awareness to a device, to let it respond in a much more powerful and natural way to the way that the user is using it. So Stream Input will take that request, will create a network of processing to provide that semantic information back to the application. We really don't want to be forcing the application developers to have to look at each sensor individually. You lose the opportunity for the middleware and hardware vendors to provide sensor fusion innovation. And Stream Input is beginning to address some long-standing issues that make it very difficult to create a high-quality augmented reality application. For example, how do you synchronize your camera input with your gyro input? The processing pipeline lengths are very different for both. So unless you have some synchronization mechanism, it's difficult to have your sensors being used correctly. And Stream Input is addressing that with universal timestamps for each of the sensor streams. Kind of sounds like an ambitious thing to do, and in some ways it is, but we have some really key participants in the industry that are helping us define Stream Input. So for example, some of you may know PrimeSense. They are the technology vendor for the depth camera that's built into Connect. They have the OpenNI API, which is their proprietary API for handling the Connect type information. Well, PrimeSense are participating, and they have contributed OpenNI to Stream Input as one input to that process. We have their chief competitors, SoftKinetic, both working together in this working group to really solve this issue in an open standard way. We also have the sensor, the gyro, and other sensor middleware vendors, such as sensor platforms, a lot of expertise coming into the working group to really figure this sensor fusion problem out for the industry. Our newest working group, relevant to augmented reality, is so new we don't even have a name for it yet, let alone a logo, is a working group that's focused on accelerating computer vision. We have in the industry open source vision libraries like OpenCV, which are awesome libraries, very extensive functionality, but they are just a big body of open source. It's actually quite difficult to figure out how to accelerate such a library, so they end up typically running on the CPU and not taking advantage of the acceleration capability of the hardware. To address that problem, Khronos has just started a new working group, which is temporarily called CVHAL, Computer Vision Hardware Acceleration Layer. We'll think of a better name. But the idea is we're going to figure out which are the key vision operations that we need to enable the hardware community to put that into accelerated hardware, and to enable applications or libraries like OpenCV or other libraries to tap into that highly accelerated vision functionality. So taking all these apps together, what are the processing steps that we need for augmented reality, and can we do it all in open standards now? Are we there yet? So, well, let's start. The camera, we need to do camera control, probably quite sophisticated camera control, and low-level image processing close to the sensor, Opencl AL provides that functionality. We need to tap off the video stream into a tracking subsystem. We can use CVHAL and Opencl to accelerate vision tracking. We need to bring in the other sensors and fuse them together into a coherent sensor stream to the application. That's the domain of stream input. We have the 3D rendering that's actually going to reach the user. We, of course, can use Opengl Es. You can also use Opengl Es for the composition because it's being fed the video stream very efficiently through EGL streams. And finally, we have the audio rendering to go alongside the graphics rendering using Opencl Es. So we're finally there. We can put a logo on each of these processing steps. Some of these are still in being built by the Khronos working groups, but you can see that we're actually getting very close now to being able to build a totally accelerated AR flow pipeline using non-proprietary portable APIs that we hope that many of the silicon vendors are going to implement. So having these APIs is great, but if they don't actually ship in real operating systems, they're not much use to anybody. The good news is that many operating systems, including Android, which is by many measures one of the key adopted OSs, are beginning to adopt these APIs. So Opengl Es has been shipping in Android since 2.2. Opencl Es has been shipping in Android since 2.3. Opencl AL has been shipping in Ice Cream Sandwich. That's Android 4.0. EGL has been there for a long time, kind of hidden under the covers, but increasingly it's going to be exposed to the developer directly, particularly with EGL streams. The rest of the APIs, not yet adopted by Android, but we hope that Google will continue to adopt them. And in the meantime, the flexibility of the NDK in Android lets OEMs ship these open standard APIs as an extended part of the NDK. They're cross-platform, non-proprietary APIs, so we can hope that many of the silicon vendors will provide the same extensions, and we can make a good case to Google once we prove the value of these APIs that they should consider bringing them into the NDK. Finally, before I break, we have HTML5. Low power silicon, increasingly powerful, means that the more and more devices are going to be multimedia, graphics, and even augmented reality capable. Different operating systems, different form factors. HTML5 does have the chance of being one of the first truly adopted cross-platform, cross-OS programming frameworks. But if we're going to really use HTML5 to develop exciting apps like augmented reality, we need much more than just more HTML. We need all of the stuff we've just been talking about. We need multi-core CPUs, we need rich accelerated 3D, we need GPU compute, vision processing, sensor fusion processing. How is the web community going to get all of that functionality quickly into HTML5? Well, one way is to not reinvent the wheel. It is to leverage the work that we've already been doing in the native API space and simply begin to lift up that functionality into JavaScript for web developers. We already have one first API, which is WebGL. Many of you might have heard of it. It's basically a JavaScript binding into Opengl Es. Now you can declare a 3D context for the canvas tag and use Opengl commands to generate 3D graphics. Already getting pretty widely deployed and a lot of innovation happening in the web space. We actually have WebCL, which is a closely related sibling to WebGL, which is a JavaScript binding into Opencl for parallel compute. We have Web Audio, which is a Google initiative for advanced web audio. And we're working with Google to see how we can accelerate web audio over Opencl. Now, there are other potential ideas. These yellow boxes are ideas and stuff we're beginning to discuss with the web community. Better camera control and image processing. Perhaps we could do a WebMax, a binding into Opencl. We need to do vision processing in the browser, perhaps WebVL provision library, and sensor fusion, we can begin to leverage the work we're doing with stream input. So where are we now? We started with the hype cycle. I think we can actually begin to turn the hype into real adoption. How is this really going to start rolling out? I think you might find that industrial applications where people are willing to take it like a tablet and to use it in industrial and manufacturing situations where real money is at stake, and we can today save people real money by using augmented reality technologies. I think you're going to see those applications really start shipping today. My personal opinion is that in the consumer space, we're going to need wearable displays, which are getting closer to really ignite augmented reality in a big way. And I think you're going to find that augmented reality perhaps isn't just an application, it's a technology that begins to get bolted in and used in many, many different types of applications throughout the industry. So, in summary, hopefully I convinced you a little bit that the silicon guys are doing diligent work. These platforms are becoming AR capable. And you're going to see more from the next few presentations about real products shipping in the market today that are going to bring AR to a user near you any moment now. And it's going to change how we interact with everything. Once these devices can sense their environment and their user and generate useful and compelling information that's merged with the environmental information, it's going to be such a useful capability. There's no reason it's not going to be pervasive. So we're going to have the silicon community taking this first step, putting these technology building blocks in place. The industrial applications could be one of the first beachheads, but there's really an enormous scope for innovation, differentiation in the consumer space, and this is all going to be happening over the next couple of years, I believe, and the presentations you'll see hopefully will reinforce that. And then finally, my sales pitch for Khronos. We are driving these open standards. We'd love your feedback if you're a developer. Don't be shy. Tell us what's working or not working. We have forums on the Khronos website. Please let us know what you think and whether we're solving your problems. If you're interested enough to actually have a voice in how these application APIs are developed and what direction they should go, please consider joining the Khronos group and getting a voice and a vote. Your input will be very welcome. Thank you very much.
Thank you, Neil, for that overview of Khronos technologies and how they relate to augmented reality.